Hey y'all, this lesson is on the beginnings of hypothesis testing. So we're looking at the null hypothesis and the alternative hypothesis. So this really ties into confidence intervals. We used confidence intervals to set up a range of values that we were confident that the population mean lied within. And so to further that, we go into hypothesis testing, and it just kind of builds on confidence intervals. Hypothesis testing is used to uh, basically make a decision about whether the parameter is possible or not. So this video is just kind of looking at the symbolism, the symbols we use and what they mean, and then some of the verbal descriptions we use to make decisions. So we'll hop right in just a second. All right, so I've shared my screen and now you can see the notes. A hypothesis test helps us make decisions about the value of a parameter. Remember, a parameter is a value used to describe a population when using inferential statistics. And remember that inferential statistics is, remember we had two types of statistics. We had descriptive and inferential. In descriptive, you're just describing your data set. And inferential means that you take those descriptions and you make generalizations about the population. So this is for inferential statistics because we're trying to make a decision about a parameter, which is a population measure. So, or a value that describes a population. So this is used for, if you have a sample and you're trying to figure out, based on the sample, a population mean, which is a parameter, then we're using inferential statistics because we're using our sample to make inferences. So an example of that is we're trying to determine if the mean weight of a bag of chips differs than what's advertised by the company. So we could pretend that I think I'm getting less chips in my bag of chips. I've opened my bag of chips and I'm so excited. And I have like this many chips at the bottom of the bag. And I'm like, wait a minute, this doesn't seem right. So you could grab a whole bunch of samples of the bags of chips and you can gather data on those bags of chips and get a confidence interval and then run a hypothesis test and all that good stuff. And if based on the decision of your hypothesis test, if you found that, let's say, for example, the mean weight of the bag of chips was lower than what the company's advertising, then you got to talk to the company and say, hey, you're not giving us what we paid for. Okay, anyway, I went deep down the rabbit hole on that one. Null hypothesis is the hypothesis being tested. The symbol we use for a null hypothesis is always is H naught or H sub 0. And whenever we write out the null hypothesis, we always use an equal sign. So you'll have mu equals mu naught, the value we're testing. And then you have the alternative hypothesis. Zoom out a little bit so you can see. And this is the hypothesis being considered as an alternative to the null hypothesis. So let's say in my bag of chips, the company's advertising, I have no idea. I don't even know what they would advertise. 0.5, I don't even know what unit they use on bags of chips, but 0.5. And I'm saying I think it's 0.3. So the hypothesis would be I'm going to test and see if the mean weight of all the samples I picked were not 0.5 or less than 0.5 or whatever. So that brings me to the symbol we use for the alternative hypothesis. We use H sub A. You might see a capital A, but either way, H sub A. And the only signs you can use when writing out your alternative hypothesis is not equal to, less than, or greater than. So I hope you can't hear my dog snorting in the background. So I wrote underneath that two-tailed, one-tailed, one-tailed. And basically what's happening is if we were to say we think that the mean weight of chips is not equal to what's being advertised, then it would be a two-tailed test. And basically that would look like your normal curve, and we're checking this region. So we're saying, I don't know why it's slow today. We're saying that maybe this is our confidence interval or something like that. And we're saying it's not, the mean weight is not in the middle here. We're claiming it might be out here. And then so that's two-tailed because there's two tails being tested. And then there's one-tailed with less than. So we have our normal curve, and then we're testing that we think the mean is less than, and then greater than, we have our curve, and we're testing, my curves are terrible, but you get my drift. So one-tailed, two-tailed. That's what that means. We're referring to a normal curve. I think actually I have a picture here I took. Nope. Okay. There's a joke up there. Anyway, moving on. Let's see. If the null hypothesis is rejected, we conclude that the data provides sufficient evidence to support the alternative hypothesis. So if we'll learn about conclusions and making conclusions in future videos, but for this one, we're just kind of talking about the wording. If we find enough evidence that we can reject the null hypothesis. So the null hypothesis is that, for example, with the bag of chips, that the company is right, that the mean is actually the mean. If we find enough evidence to reject that, then we can conclude that the data provides sufficient evidence to support the alternative hypothesis. Or you might hear something like, the test results are statistically significant at the alpha level. And so basically, we would be choosing an alpha level, or it would be chosen for you, and that alpha level refers back to kind of the confidence intervals, and we have that Z sub alpha and all that good stuff. If the null hypothesis is not rejected, and the wording there is important, we conclude that the data do not provide sufficient evidence to support the alternative hypothesis. Or you can say the test results are not statistically significant. It's so hard to say, at the alpha level. And this is important. I put this in all caps because this is so important. We never, ever, whoops, wrong word, but still all the same, accept the null hypothesis. We never, ever, 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 ever accept the null hypothesis. We can not reject it, but we never accept it because we're just making inferences. We don't have strong, you can't accept it. So we never use the word accept. We can provide sufficient evidence to support one or the other, but it's never accepted. Okay, that's important. Never, ever accept. Moving on. So I have an example here, and this is just kind of using the symbols and stuff, what you might see. Express each alternative hypothesis symbolically, and identify the hypothesis test as two-tailed, right-tailed, or left-tailed. So in the first example, we have you want to decide whether the population mean is different from the specified value. So if you're writing both hypotheses, we have H naught is mu equals mu naught. That's our null hypothesis, and we always use an equal sign. And then the alternative hypothesis is mu for does not equal or is different than, we would use does not equal, mu naught. So we have our null hypothesis, which we always use an equal sign. Sarge, calm down. And we have our alternative hypothesis, and we can use 3 different signs depending on the wording. And if we go back to our standard normal curve, when it was not equal to, we had 2 possibilities in the tails. So this is a 2-tailed test. So go ahead and try the next 2. Pause it, try it, come back. So when you come back, you should have the null hypothesis. And then it says the population mean is less than a certain value. So that's our alternative. And less than would be left-tailed test. Flagging, I don't know. And then the last one, our null hypothesis is the equal sign always. And then this one is greater than. So greater than, which would be a right-tailed test. Not too shabby, right? For example 2, we have the conclusion that you would make based on a small significance level. So like 0.001 or 0.005 or whatever. And this is just getting you used to the wording. So when we say the null hypothesis is rejected, so we found evidence to reject the null, do we accept the alternative hypothesis? No, we never do. We can say the data, whoops, spelled that wrong. Data provides sufficient evidence to, that's not to, that's silly, to support the alternative hypothesis. You could also say the data provides statistically, or the data is, what was it? Statistically significant, basically is what I'm trying to say. The test results, that's what it was. The test results are statistically significant at whatever alpha level, whatever the alpha level is. So basically I'm pulling this wording from here, what we would say in each case. So when the null hypothesis, that was really late, when the null hypothesis is rejected, you can say that the data provides sufficient evidence to support the alternative because the null was rejected, or you can say that the test results are statistically significant, which means we reject the null. And in the case where the null hypothesis is not rejected, then we would say the data does not provide sufficient evidence to support the alternative hypothesis. Or we could say the test results are not statistically significant at whatever alpha level. Okay, try this last one. And then we'll check it in just a second. If you'll zoom out in a minute. Go ahead and try it. All right, so the national mean annual salary of teachers in public schools is $55.4 thousand. A hypothesis test is to be performed to determine whether the mean annual salary of teachers in public schools in Texas is greater than the national mean. So the value being tested is $55.4 thousand, which means that your null hypothesis is that the mean is equal to $55.4 thousand. And the alternative hypothesis, the one that we're testing, is we think the mean might be greater than the national mean. And since it is greater, this would be a right-tailed test. That's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I will be happy to help. Bye, y'all.